Alright everyone, welcome back to the day 37 of our daily leetcode challenge, and today we have got tuple with same product. So in this question they have provided us with an array called nums, and all the values in nums are distinct and positive integers, and the value of the length of this array called nums is up till 1000, and the values in nums can go up till 10 to the power 4. They won't be negative, they won't be 0, but they want to be only positive integers and all of them distinct. From the given array called nums, we need to find tuples a, b, c, d such that a product b is equal to c product d. We need to find all such tuples a, b, c, d such that a product b is equal to c product d. So if we take a look at the first example, 2, 3, 4, 6, we find that 2 multiplied with 6 is equal to 12 and 3 multiplied with 4 is equal to 12, meaning we have a tuple called 2, 6, 3, 4, right? 2, 6 multiplied with each other is 12 and 3, 4 multiplied is 12. So this is a valid answer. But if you see, this entire combination that we got 2, 6, 3, 4 has been kind of mutated 8 times. It's like a permutation of all these values 8 times. So for a valid tuple that is formed, the possible answer with this alone generates 8 possible answers. So what they mean by that is, I want you to understand one thing before we even proceed with the problem, which is, let's say I said that there is a tuple called a, b, c, d, where all these values are distinct obviously, and the property is a star b, you can say a product b is equal to c product d. Then from this one combination we're gonna get 8 valid combinations. Let's see how it's happening. That is why if you see 2, 6, 3, 4 is permutated 8 times. How this is happening, let's take a look. So first combination is a comma b, c comma d, that we just saw. This is one. Then we fix a, b and rotate, flip c, d. So we have a, b fixed and c, d are flipped. So it becomes d and c. Now what we do is we fix c, d and flip a and b. So this becomes b comma a and c comma d as it is. And then in this case the same thing is gonna happen. We're gonna fix we're gonna fix dc and then flip a and b here. So this will be b comma a and d comma c. So this is how we got the first 4. So far we got 4. Now for the remaining 4, what we need to do is we just need to flip the positions of c, d and a, b. Just flip these positions. Flip c, d, put c, d here and a, b here. Once we do that, we'll get something like this. c, d is put here and a, b is brought here. Now we need to do the same thing which we did here. Same thing we're going to do on these values. So we're going to fix c, d and then flip a, b here. So c, d is fixed and we're going to we have flipped a, b. So this becomes b a. Then a, b is fixed, flip c, d. So this becomes b, c, a, b. Same thing here, b, a is fixed, you flip c and d. So this becomes d comma c and b comma a. So this is how we get the other 4. So what I mean is, for a given pair, for a given tuple a, b, c, d, this is how those 8 combinations are happening, and these are 8 valid tuples. So like if you get a, b, c, d as a single combination where the a star b is equal to c star d, if this is a case which is happening for 4 values which are unique and it's a tuple, for this single tuple we are getting 8 combinations in total. 4 plus 4, which is equal to 8. This 8 that we are getting is going to help us later to reach our final answer, because let's say that I find a pair a comma b and x comma y, wherein a star b is equal to x star y. This would eventually mean that for this one single tuple that we got, the amount of the number of valid tuples that are actually getting generated will be 8 times, or 8 of it, because of the combinations that we just saw. That is why for a single answer 2, 6, 3, 4, which we saw here in this case, right, we started with 2, 6 and 3, 4 in the smaller example 2, 3, 4, 6. We saw that 3, 4, 2, 6 was a valid pair. So 2, 6, 3, 4 was a valid tuple, wherein 2, 6 like multiplication of 2, 6 is 12, 3, 4 is 12. So this is like a valid answer. For this entire one tuple, we got 8 possibilities, 8 possible answers. That is why you see all these values here. The same thing that's happening here as well. in the case of 1, 2, 4, 5, 10, we saw a combination as 1 comma 10 multiplied is giving us 10 and 5 comma 10 multiplied giving us 10. So this one single tuple is repeated, kind of mutated or permutated 8 times. So that's how we get the first 8. And again the second combination that is happening is 2 comma 10 4 comma 5, 2 comma 10 4 comma 5, this right here, and then this again getting permutated or mutated 8 times. So in total we are getting 8 plus 8, which is 16. So this 8 that we got here, we're gonna keep this in mind and use it later to reach our final answer. But what if I told you, like, what we can do instead of multiplying with 8 initially, what if we are able to find all those pairs, like all those tuples for which we are getting the answer, or like the pairs wherein A star B is equal to C star D. If we get a count of these pairs, like this is one and then this is one unique, right? We got these values. If we get the count of such pairs, or you could say such group of values for which the product is same, we can count, we can get a count of these values and eventually multiply them by 8 and return it. So that's how we'll be reaching to our final answer, by multiplying them by 8. But first what we need to do is we need to find count of all such pairings A, B, C, D. We need to find count of all such pairings A, B, C, D such that A star B is equal to C star D. So how we can do that, let's take a look, and how we can find a count of all such values wherein A comma B, or like all those 4 values, unique 4 values from this nums, such that A star B is equal to C star D. And once we find all those possible counts of such pairs, we can multiply that count value with 8, because we know each possibility or each count gives us 8 different answers. So if we get a count of all such values, once we have that count, we are going to simply return a count star 8 in the end to reach our final answer. So this is one. The other thing is, now let's see how we can actually find counts and how we're going to use hash map in that case. So hash map is going to help us find the count of such pairs such that the product of two values, like let's say we reach 2 here, and then like in this case you see that 3 comma 4 and 2 comma 6 is a possibility, because 4 comma 3 is 12 and 6 comma 2 is 12. So we're going to see how a hash map is going to help us find a count of all such pairs. So let's define a hash map. This is our hash map, which will be empty initially, and we're going to also have a variable called count. So again, like we know that multiplication is like a commutative and associative property as well. So A star B is equal to B star A. So if I find all the possible kind of multiplications of 1, if I start with 1 right here and try to pair it with 2 first, and then 3 first, and then 4, and then 6, and then 12. So this is all the possible pairings that are going to form with 1 in this array, which is all the values ahead of it. When we come to 2, to find all the possible pairings with 2, there is no need to go back, because with 1 comma 2, 1 star, if you do 2 star 1 or 1 star 2, it's the same, because it got covered in the previous iteration, the previous value. So you don't need to go back, you just only gonna go forward. Whatever values there's forward of the array, we're gonna pair it with that. So with 2, it's gonna be 2 comma 3, 2 comma 4, 2 comma 6, and 2 comma 12 again. We won't be going back. The same thing is gonna happen with 3 as well. With 3, all the possible pairings is gonna be with 3 comma 4. There's no need to do a 3 comma 2 go at the back, because this already got covered via the 2 which was previously we iterated. So 3 comma 4 is gonna be a pairing, 3 comma 6 is gonna be a pairing, and same with 3 comma 4, 3 comma 12. Once we reach 4, there's no need to go back again. The only possible pairing for 4 will be 4 comma 6 and 4 comma 12. So what I mean by that is, if you see for each value I which is starting from here, the j value can start with an I plus 1, to find all the possible pairings. So I hope you are getting this, because this is how we will be starting our loop. We will be starting with 2 for loops. One will go all the way from this, and the other j will start from here. J will start basically from I plus 1. For each I which is starting from here, let's say initially I is starting from here, the j will start basically from I plus 1, and this will keep on going. For each I, the j is gonna start from I plus 1 and iterate. Then I will shift here in the second iteration, and for this I, the j is gonna start from here, I plus 1, and then keep iterating, because there's no point taking care of the back values, because this already got covered in the previous iteration. I hope you are getting this, because this is how we are going to start with our 2 loops, I and j. So this is how we are going to form the pairings. Now let's see how we can use this hash map to get a count of all such pairings a comma b, c comma d, such that a star b is equal to c star d. Let's see. So we gonna like the way I discussed, the way we are finding pairs, we're gonna just make a product of it and keep a count in the hash map. So let's do a dry run on this one. This is our hash map. This will form a pretty big hash map, so I'm keeping space here. We're gonna iterate this entire loop exactly how we discussed, and we're gonna keep a count of all the products that we are seeing so far. We start from 1, and then our jth will start from here. So our first product that formed is 2. Do we have a 2 in the hash map? No, we don't have it. So we put a 2 in the hash map and set its count to 1. We also have a count variable. Initially its value will be 0. This count is going to be nothing but the count of all such pairs a, b, c, d, such that a star b is equal to c star d. This is what the count is going to be. This is one single pair. We know that this eventually will give us 8 more pairs. Not 8 more pairs, like this is nothing but like a version of one of these 8 pairs. But we just want all those pairs such that a, b, c, d and a star b is equal to c star d. Let's just find such pairs. We know that eventually this will be equal, like a single count represents 8 more, but we just need to find such counts first, so that in the end we just return into star of 8, like we discussed earlier. We just return a count star 8, but first we need to find such counts a, b, c, d, such count of pairs a, b, c, d, such that a star b is equal to c star d. So let's iterate now. We started with 1, we paired 1 with 2. 2 was not in the hash map, we put 2 in the hash map, set its count to 1. Then the other pair is 3. We didn't find a 3 here, put 3 in the hash map, set its count to 1. Then we have 1 comma 4. Didn't find a 4 in the hash map, put it in the hash map, set its count to 1. Then comes 6, same thing. Then comes 12, same thing. So now so far we have found no such pairs, like these are the initial values. Now this is like all the pairings of 1 with these values right here, all these pairings that we saw. 1 pair with 2, 1 pair with 3, 1 pair with 4, 1 pair with 6 and 1 pair with 12. This is what these products define. 1 pair we got, like single count we got, like 1 this is basically the a star b. Now with the pairing of 2, we are basically doing a c star d. If we find a c star d in the hash map, basically where these two are equal, in that case, the moment we find a c star d, which will be starting from 2 here, if we find that, we're going to simply get whatever time that product appeared in the hash map, which is equal to 1 right now, and update that to the count. You will see what I mean in a moment when I start iterating from 2. So let's iterate from 2 now. So 2 comma 3 is 6. Do we have a 6 in the hash map? We see that yes, we do have a 6 in a hash map. How so? Because again we paired 1 and 6, and then now we are again pairing 2 and 3 with it. So this basically means, since we have a 1 in the hash map, we're going to update the count with whatever value of 6 we have in the hash map. Since 6 is present in the hash map, we're going to update the count, since like we reached at 2 comma 3. We found the product as 6. Do we have a 6 in the hash map? Yes, we have a 6 in the hash map. What does this mean? This means that we did a c star d and its product is equal to a star b, which we previously did. So this is nothing but a single pair, which is represented by the count right here. So we need to update this count to whatever product's count is present in the hash map right now. We found a 6 in the hash map, it's 1. We update the count value with whatever the count of that product is it in the hash map, which is 1. So we update the count with a 1. We found a value. Now we updated a count with 1, which whatever is the current count of the product. But then again, since we reached a 6 again, this needs to be updated to a 2 for further iteration. So this is now getting updated to 2. This right now is 1, because this is the single pair that we just saw. C comma d paired with a comma b is a single pair, even though there are 4 values, but this is a pair in its own. So this gets updated to 1. But now we need to update the value of 6 to 2, because this is the second time we are reaching a 6. Why so? Because if, let's say, further down the line we reach a one more time where there is a possibility of a 6, let's say there's another pair called x comma y, for which we found a 6. In that sense, when we take a look at the hash map, we'll say, alright, do we have a 6 in the hash map? Yes, we do. And what is the count that we have? Which is 2. So we have to add a plus 2, because now we'll have 3 pairs, which is like c comma d, a comma b as a single pair. They were a pair initially. This is a single pair. Then we again found x comma y again appearing. What does this mean? That this is already getting paired up. Now this x comma y is also getting paired. So x comma y can be paired with this and this as well. So that is why we are getting a 1 plus 2. So 3 pairs in total. C comma D, A comma B. Both these products are same. Product of x and y, C, D and A, B, all these values are same. So with these three, we are getting a total of 3 pairs. This paired with each other, and then x, y and A, B getting paired with each other, and then x, y and C, D getting paired with each other. That is why we are getting updating the count value to plus 1, so that in the further iterations once we get, we update it with a plus 2, not a plus 1, because the pairs are, this is how the pairs are getting formed. I hope you are getting this, because this is how we use hash map to actually get the pairs, the number of pairs that are going to form. So now our we reached a 6, right? We saw that we were at this one 3 comma 2, this gets updated to 1, so our count gets updated to 1, and this will again get updated to 2 for further down the line if we get any more sixes. So this is done. Then we come to 2 comma 4, which is 8. Do we have a 8 in the hash map? No, we don't. Then we come to 12. 6 comma 2 is 12. Now this is the same thing. 12 is getting appearing here. What is the count of 12 right now, which is 1? So we add 1 to the hash map, plus 1 to the count, and then update this to 2. So again we saw that 2 comma 6 is 12. We already found a 12 in the hash map. So right now, the moment we found a 12, in this case, the moment we found a 12, the count was 1. Initially the count was 1. So like this count, 1 comma 12, the count is 1. We found another pair called 3 comma 4, for which it's 12. 2 comma 6, for which it's 12. So now we're going to update the count with a plus 1, because it's like a single pair forming, which is 2 comma 6 and 1 comma 12. This is a single pair getting formed. That is why we're updating with a plus 1. Now this will get updated to 2. For further down the line, if we find another pair, which we'll see, which is 3 comma 4, this 3 comma 4 is going to get paired with these two, so it's going to be plus 2. Plus 1 we got from the previous one, and then again 2 more we will be getting, like we discussed earlier. So that is why it will be a plus 2 later. So 2 comma 6 is done. Then 2 comma 12 is 24. 24 is not in the hash map. Let's add that. This gets updated to 1. So 2 is done. Now we are at 3. 3 comma 4. This is a 12. Do we have a 12 in the hash map? Yes, we have 12. And what's the count? The count is 2. That is why we're going to do a plus 2 now. Now this 12 which we just found, we are going to update it. So we update this to a 3, because if further down the line we got any more 12s, we'll update that. So now this is done, and the other pairing is 3 comma 6, which is 18. 18 is not in the hash map. Let's add that. Then we get 12, 3, 36. 36 is not in the hash map. Let's add that. So 3 is done now. Let's come to 4 now. So 4 comma 6 is 24. 24. Do we have a 24 in the hash map? Yes, we have a 24. Since the value is 1, this means that this 4 comma 6 getting paired up with 2 comma 12 is a single pair. That is why this value is 1 right now. 3 comma 4 getting paired with another 12 comma 2. 6 comma 4 getting paired with another 12 comma 2, giving us a single pair. This is why the count is 1 right now. So we update a 1 plus do a plus 1, and then later update this value 24 from 1 to 2, so that if later we found another pair for which the value is 24, we can update a plus 2, not a plus 1, because we saw how the pairings are working or forming. So and then 4 comma 12 is 48. We don't have a 48 in the hash maps. Here we add that as well. Then 4 is done. Then comes 6. 6 12 is 72. We don't have 72 in the hash map. We add that, and that's pretty much it. The loop ends. So this is how we are getting the count, and once we add all those count, so these counts are nothing but all those pairings x, y, a, b, for which the values are getting satisfied. X star y is equal to a star b. These are all the count values that we have. If we add them, we'll be getting a 5. So now we know that each count or each pair is going to give an answer to 8 more. Basically, like each count is a version of those 8 possible counts, 8 possible answers. So that is why in the end we're going to just return a 5 star 8. Whatever the count comes, we just multiply with 8, and that is why the answer is 40 in this case. We'll see how it's happening. I'm going to run this test case in the example as well, and then we'll see why the answer is you'll see the answer is actually 40. So let's try to code this up. because as we said, the loop is gonna run from I and I plus 1. So this is how the I is gonna run up till length of nums, and j is gonna run from I plus 1 up till the length of nums, up till the end. We also need to define a hash map. And the count variable. The product is that we are going to get will be nums I star nums j. We need to check if this product is in hash map. If it's there in hash map, then we know what we need to do. We need to update the count with whatever value currently is there in hash map. Whatever the count of this product is in the hash map, we're going to update that. And if even if it's there or not there, we're gonna have to increase whatever this product we got and set its count with a +1 in the hash map. Initially, if the product is not there, it will be 1, and then if it's found there, then again we will increase it to a +2 with a +1, so that this count gets updated accordingly, that we just saw. So now that we have that, we'll get our count as well, and we know that this count will get multiplied with 8. So in the end, we just need to return a count multiplied with 8. So if you see, the third test case that I have here is nothing but the test case that we just discussed, and the answer was 40. So if I run this now, you see it's satisfying those test cases, and the answer for that last test case that we discussed is 40. So let's try to submit this. Yeah, so you can see it's satisfying all the test cases. So this is how the algorithm is working. We are finding pairs and maintaining a count of it, and then multiplying with an 8. I already explained why we are multiplying with an 8. You can go through the diagram as well, and this is how the algorithm is working. This is a O(n) square because we are doing 2 for loops, but since the length of the array is not much, is up till 1000, so this is a pretty efficient solution. So if you try to analyze it, it's going to be O of n square, as you can see. So that was it for today, everyone. I'll see you in the next one. Like and subscribe. Bye.